Okay, first thing we got to do is blow an envelope. We got a piece of 1¼ inch glass. 1¼ inch. This is inch glass, 1 inch glass. There we go. Okie doke. Now for doing this, we've got the blow tube connected to the back end of the tube glass, and we'll use our big tip. Alright, that gets our envelope 2 inches in diameter. Okay, the next thing we have to do is put the filament stem on the end. Alright, that's pretty close. Now, we'll put a little bit of a flare on the end of this one. Okay, now we have to blow a hole in the end of the tube. To do that, we heat the glass, we use our pressure inside to just pop the glass out. A little bit thick. let that cool off a little bit. Alright, next we're going to cut it. It's cool enough now to where it won't vaporize our cooling fluid. Okie-doke. Okay, now we're going to make the flare that goes in the back end of the tube. See, that's our flare. Okay, and we've got the welder set up. I'm going to go in low, tungsten nickel. Ready to go. Okay, so I take this. Been over a year since I've done this, so I've got to remember what the heck I'm doing. Okay, and a piece of tungsten wire. Okey-doke. Nope. Now, okay, we're doing copper for connecting wires. Okay, I got one little piece. That's not enough. I need a lot more. See, we need something that solders good. Okay, I need pieces of nickel. Okay, this is nickel tubing, and we use that to solder the copper onto the tungsten. Okay, I slip that nickel tubing over the wire. All right, let me go cut that off. Okay, and we need about maybe 2 inches. Okay, and I need 3 of them. Cut it off. Okay, that's a little long. Better to have it break off now than to break off when we're doing it in the glass. Okay, I'm going to run the current up a little bit more. Okay, get some more. Okay, tungsten. All right, that's not going to break off. Looks good. Right length. High, all the way up. Full power here. Okay. All right, now that gets us our deal. We have the part that's inside the tube. We have the feed through, which is tungsten, and then we have the copper lead wire that goes out the back, gets soldered into the circuit. All right, now we have to take the electrodes and we stick them to a piece of tape. Okay, we put plate, grid, and plate. Okay, now I need another one for the filament. Okay, this will hold the wires while we do the operation. Next thing to do, seal them into the glass. See, this one will go into the flare, like so. Okay? The other one will go into a piece of glass for the filament. All right, let's go fire up the machines. All right, now we have to do a screw hitting. Okay, the first thing we have to do is heat the tungsten to oxidize it slightly. Okay, that'll do it. Okay, we've pinched the wires to hold them in place. We have not made the seal yet. Okay. Okay, there we pinched to make the seal. Okay. All right, we'll let that go ahead and dry or cool off. Okay, now we have to set up to do the filament. ahead and oxidize the tungsten. Warm up the electrodes so they don't bubble. Okey-doke. All right. Okay, the next thing we have to do, we have to test the flare to make sure that it doesn't have leaks. Okay, the next thing we've got to do, we've got to get our electrodes put on here. Now, these long ones are going to be made into the grid itself, and the shorter ones will fasten to the plates. There's going to be two plates, two wings. Okay, so we're going to take and we're going to bend. So we take the plate ones, we're going to bend them out of the way, like so. Okay, now, okay, and those are going to be our grids. Now, to make the grids, okay, that's one of them. This is the same way they made them back in the 1920s. You know, they did not use any kind of tools or machines. They were all done by hand. So when they were done making a batch of tubes, they just, these characteristics were just all over the place, depending on how carefully the people making them were. And looking at some of the original audions, they were not very careful. Well, or else they just simply couldn't do it. They were trying to be careful and they just could not do it. Okie doke. Now we just trim. Okay, that gives us our two grids. It's a trick. Okay, that doesn't look too awful bad. Got space between them for the filament to go up in there. Alright, now we have to make two plates. Now for plate material, alright, I need some metal. Okay, here we go. Now I'm going to take this and flatten it out perfectly flat. Oh, I got some here. Okay, here's a piece that's already been flattened out. The way they're flattened is you put it on a piece of flat steel plate and put another flat steel plate on top of it and hit it with a hammer. And then the shock flattens it out perfectly flat like a sheet of paper. Okay. Let me clean this down to being sterilized. I'll use this sterile rag that I had laying on the bench here. Okay. That is going to do it. Now we get a snips. Okay, that's double, so that makes two plates identical. Now we need two holes in there for the wires to go through, the retaining wires. So we have to, first we'll center punch them to get a place for the drill, and then we'll get a small drill bit. Okay. Okay. Now, we can see here, the holes are right in the same position. Next, we're going to cut the bottom off of it. Okay, and that gives us two plates that are identical. Okay. Okay. Number two. Now, the original audions had the edges of the plates diagonaled. They just took the corners and just snipped them. So they just kind of at a slight diagonal. I've seen some of them that did not have them diagonal and some of them that did. So we'll just do it, since it's easy. Okay. Now, next thing we do is we mount them on the assembly. Okay. We bend these up. Okay. And out. Okay. We do one. We take a plate. Okay. Okay, that gets one plate on there. Now we trim the extra off. And we pinch these bends firmly so the plate can't wiggle around. Okay, and then we can just bend that. See, and that gets us one plate mounted. Okay, now we do the same thing on the other one. Okey-doke. Bend that. There. Careful, careful. You go out of control, you can screw it all up. Okay. All right, now we pinch it. Very good. All right. Right, and there's our electrode assembly. All we got to do now is make the filament, and see, this will go up inside here like that. The filament we make here. Okay, and we'll clean. Okay, we cut them off, and then we flatten them out. If we don't flatten the wires, when we pinch it down on that, the rounded surface of the wire will cut through that piece of tungsten like it was glass. So we have to flatten these out. Okay, so we now have flat surfaces there, so when we bend it over and put the tungsten wire, filament wire on there, it isn't going to cut the wire. All right, we need some tungsten wire. Okay, this is thoriated tungsten wire that's used for making the filaments. It's about 2% thorium, which gives it really good emission. Okay. All right. It's on there. Now we make a loop. Okay, and then we crimp the other side. All right, and that little loop is our filament. Okay, now we cut that off. Okay, now what we're going to do is we're going to bend the ends around, and then we're going to weld it. To do that, like that. Damn. Even with glasses, I can't see the damn thing. It's so small. Okay, now we take it and weld it. Okay, and that's our filament. All right, and that has to fit up inside there. Okay, no problem. All right, we're ready to start assembling the tube. We've got our, see, and this will go up inside there like so. All right. Now, first thing we're going to do is we're going to warm the thing up with the annealing torch. We've got the element positioned up in there just right. Okay, the first thing we got to do is take one point on the flare and seal it onto the envelope. Then we very carefully position it to be exactly right, and then we go on around and seal it. Alright, that looks good. Alright, now, that takes the flare and it connects it to the envelope. Okay, we need to go that direction just a small amount. it's almost perfectly centered. Okay, now we go ahead and seal the thing completely on there. Okay, now I'm going to put a little pressure with the blow hose on there, and I'm going to expand it out so that it doesn't have too thick of a glass. Okay, we'll just go ahead and cool it down. Okay, now before it's totally cooled down, we have to get the evacuation stem on there. Okay. All right, we're going to put the evacuation stem right here. So what I'll do is I'll put a little pressure inside there with the blow hose and pop a hole in it, and then seal the tube onto it. Okay. Gorgeous. Very good. Okay, now I want that to be parallel. We just let that cool off, and then we turn it around and we put the filament in. This is crazy. This is twice I've forgotten to turn the camera on. Alright, the first thing I did with the camera off, of course, being an old man, so old that my brain is totally befuddled, can't remember to push the button on the camera to keep it going. I cut this stem off the right length for the base to fit just right, okay? Then I take this and put it up inside there and found the exact position to cut the tube off, this tube off, so that the end will be right even with the end of this. Here. So when we put it up in there and have it positioned just right, we'll melt the glass together and that'll seal the tube with the filament right in position. Alright, and this time the damn camera is on. I don't know. Okay. Looks really good. Okay, next, take the filament. That's going to be just right. Looks really good. All right, next we have to heat it up and seal it on there. Okay, first, this is the most critical part of putting the tube together. Okay. Now, it's sealed on there in one position. I've got to look carefully to see. Okay, it's a little bit to the back, so I've got to warm it up and move it a little bit. Okay. Ooh. Okay, it's perfectly positioned. Now I'm going to get the other side here. made a mistake. I forgot to put a getter in it, so the tube's going to be short-lived. So I just went ahead and vacuumed it. I put it in the oven and baked it for 4 hours at 800 degrees. And you know, it has good emission and all, but it's going to gas up in a matter of weeks. So we're just going to seal it off and yeah. Okay. All right, we'll go ahead and finish it off. And, you know, it's practice. This is a practice tube. Okay. We'll go ahead. We're going to finish this audion off. Okay, it's been 3 days since I sealed it off. That video that I just got through with. Okay. Okay, I got to have a piece of insulation down inside there. What I do is I take a piece of, this is Teflon insulated wire, and I just cut a piece of insulation and I slip that onto here. Okay, and that goes down inside there and keeps the wires from shorting out. Okay, those are the filament wires. All right, now we're going to hook it up to the, I'm going to test it before I do this. If it's gassed up already, then I'm not going to bother with it, but we'll see. See, this has no getter in it. We forgot to put the getter, so yeah, we're on borrowed time. Oh, that's whew. But this is the first audion I've made in over a year, 2 years maybe. Okay, I need the grid. Is that one there, and the plate is here. Okay. Whew. Wow. That's working great. Okay. Okay, here is plate voltages. We're going to run at 67 volts, and we've got the filament at 2 volts. Plate milliamps is 2.5 milliamps, and our transconductance is 200 GM. 200 out of that little sucker. That's good. Okay, now if we run it at, let's say, 45 volts, okay, we're getting about 1.25 amp, and we're getting 150 GM. Okay, so anywhere between 45 and 67 volts looks good. Now if we go up to 90, whew, we're starting to get into pretty good plate current. We're 4.5 milliamps and 270 transconductance. Now that's using thoriated tungsten filament. Okay, and you can see from the brightness of it, it's not really that bright. You know, it's less than the brightness of a flashlight bulb, of the old-fashioned flashlight bulbs. All right, so it's in perfect shape. We haven't leaked up at all so far. Okay, now I've got a lot of 220s here, so I'm going to use them up. I don't have as many 120 volt. These are getting hard to find. I mean, these incandescent bulbs. That's a 120, 250. Okay, that's a 250 volt. Now what I do is grind 120 off of it. It makes it a little more authentic. Okay, that gets the writing off of there. It'll fade out here in a matter of months, and then it'll look just like a plain old base, like back in the old days. Okay, next we have to mix up a little bit of JB weld. Okay. Oops, forgot to clean that hole out. Okay. Good move. Put it right there. Okay. Okay, now we have to let that harden. Take about 5 minutes. Okay, I got to get some wires for the other end of the tube. All right. Here we have our audion wire. Got to get out there. Okay. See, there's a piece of woven sleeve. The wire itself is junk. We throw that away. All right. Let's see. Got more. Okay. Wire we throw away. Okay. That gives us a red and a blue. The old original audions were a red and a green, but we don't have any green. We'll paint it green, or we'll just leave it blue. Now, this is bronze wire. It's very, very stiff and strong and flexible, and we use that for the audion wire so that it has no tendency to break off. This is also very difficult to find. I got a pretty good sized roll of it here, so that ought to last me till I die. Doke. Okay, now, stick it in the glue. Okay, and we can slip that into here. Okay. Go. All right. See, and then this will fasten into the end of the tube. Good. Another one. Oh. Yeah. Okay. Okay, that's pretty much. It's not hard yet, but it's close to it. Okay. Is it correct? Here. Okey-doke. And then this one. That goes to there. Good enough. Okay, that gets our base connection. Okay, now for these, okay, I've got to hold this. I don't know if I can work on it. Okay, we don't want to squish it too much or we'll pop it. That'd be great. Pop the tube. Okay, dadgummit. Oh, doke. You have to be very careful of these wires. They're extremely soft from being heated up to red hot when the tube was baked. It was 1,000 degrees Fahrenheit, and those wires were right at red hot. But we don't have to bend them. Okay, now you take those and you just cut them off. Okie doke. Now that gives us our two wires there. Now, which one's which? Okay, let's see. Grid, plate. Okay, plate is on the right, and a grid is on the left, okay? Just, oh, for heaven's sakes. It's on there. The red one for the plate. Okay. Alrighty. There. Okay, very good. All right, more JB weld. Doke. Okay. Now, we're going to let that go ahead and harden for an hour, and that will fasten the wires into the tube. Alrighty. Let's go ahead and test it again, make sure it's good. There's the filament. It lights up. Okay, now our plate is red. That grid. Looks good. We're 67 volts. We got 3 milliamps, 200 transconductance. Now, you can see, all right, when we go to 22 volts plate, we get about 75 transconductance at about maybe 1/4 of a milliamp. If we run the grid voltage up, negative grid voltage, it cuts the tube off, as we'd expect. Okay, go up to 45 volts, and our transconductance is about 150, and a plate current of 1¼ milliamps, maybe 1½. And then we can go up to 67 volts. We're pushing 200 transconductance, and we can go up to 90 volts, pretty much saturate out at 200 transconductance. So the linearity is starting to get, we don't have enough emission. Okay, so if we run the voltage up a little on the filament, see, we can get more current out of it, but we have to watch out. We don't want to overdo it. The filaments, these filaments of that size will run a few milliamps like this, 5 milliamps. They'll run 5 milliamps, okay. So we can run this tube at 90 volts, okay, and that's about a 1 3/4 volts for filament, and that gives us a 200 transconductance. And that would be very nice and linear. Okay, now if we run the voltage down, okay, that's about 1.25 filament voltage, and we saturate out here at about 67 volts at 100 transconductance. Then if we run it up, run the filament up, we can get more emission out of it. Get past 200, and if we use our grid bias, we can cut the tube off. That's putting negative 15 volts on the grid. Okay, come back down to 0. Okie doke. There's no trace of blue glow in there either, so there's no air in it yet. We may have a good seal on it. That means the tube may last for years without a getter. Okay, that's it. All right, coming up, Next video, I'm going to use this tube in a 1912 radio. It's a replica, but it's just like a radio was built by deforest back in 1912. And we will take that radio and connect it up and operate it. Next video.